In this video, we will be discussing transformers specifically for EDEXCEL. So, specification point 125 states that we need to understand the factors affecting the EMF induced in a coil when there is a change of current in another coil linked with this coil. But before we get to that, we need to understand, well, what are transformers? Transformers are devices which can increase or decrease voltage from electrical generators. Transformers have a primary and secondary coil which are linked together by a laminated core. The core is laminated in order to reduce eddy currents. In reality, the electrical energy is not all conserved. A lot of it is converted into heat by eddy currents. So by laminating the core, you reduce the amount of eddy currents present in the core and increase the efficiency of the transformer itself. So we've understood what transformers are. Now we need to know about, well, how do they work? So an alternating current passes through the primary coil, producing a changing magnetic field. The changing magnetic field then travels through the iron core and into the secondary coil. This would produce a change in magnetic flux, and by Faraday's law, an EMF will be induced in the secondary coil by the change in magnetic flux. The EMF induced in the secondary coil has the same exact frequency as the voltage applied in the primary coil. Now we look at, well, deriving transformer equations. So let's examine the following equations. The top section represents the equation for the primary voltage obtained by the product of the number of loops in the primary coil multiplied by the rate of change of magnetic flux with respect to time. The bottom section represents the exact same situation but for the secondary coil. The rate of change of magnetic flux is the same for both equations due to the frequency of the induced EMF in the secondary coil being the exact same as the primary coil. The rate of change of flux for both primary and secondary coil cancels in the equation, so you would end up basically with a ratio of primary voltage to secondary voltage, which equals the ratio of the number of loops in the primary coil to the number of loops in the secondary coil, and vice versa. So, well, how we need to look at this. How does the number of coil loops affect the induced EMF? So if the number of loops in the secondary coil equals the number of loops in the primary coil, then the alternating voltage induced in the secondary coil equals the alternating voltage applied to the primary coil, which is very rarely used in transformers. These next two bullet points are the ones that are more commonly used, which I'm about to explain. So if the number of loops in the secondary coil is greater than the number of loops in the primary coil, then the alternating voltage induced in the secondary coil is greater than the alternating voltage applied to the primary coil. In this case, potential difference is increased and the transformer is described as being as a step-up transformer. Now, if the number of loops in the secondary coil is less than the number of loops in the primary coil, then the alternating voltage induced in the secondary coil is less than the alternating voltage applied to the primary coil. So here the voltage is reduced and the transformer is described as a step-down transformer. I hope this video has made sense and cleared any questions anyone's had about transformers. Thank you all for watching and goodbye.